Hi dear students, today we are going to see second method for water treatment, and that method is ions exchange method. Ions, that is what? The cations and anions, and both are getting exchanged. So here this method also known as demineralization or deionization, and for in-sem examination there will be a fixed question on ions exchange method. So as far as principle is concerned, we required two resins. First one is a cation exchanger resin and second one is an anion exchanger resin. So here water containing a cations and anions, both cations and anions. First we are going to pass through cation exchanger resin, cation exchanger resin. So here all cations are captured and in exchange release of H plus ions in water. After that, water pass through second resin, and that second resin is anion exchanger resin where all anions are captured and in exchange release of OH minus ion. And finally we get water which is completely pure and free from all ions. So after principle we will see what exactly present in cation exchanger resin. This one not necessary to write in the examination, just for information I am telling that how cation exchanger exchanges cation and releases H plus ion. So in cation exchanger resin there is a polymer with side group benzene, and benzene carries sulfonyl group, and sulfonyl group with loosely attached H plus, and that loosely attached H plus exchange with incoming cations. For writing a reaction you have to use simply RH2. Now we will proceed towards second resin, and that second resin is anion exchanger resin. Again here one polymer is there with side group benzene, and benzene carry tetraammonium group, and that tetraammonium group carry loosely attached OH minus ion. Loosely attached, so it can exchange very easily with incoming anions. For writing a reaction, shortly you are going to write R-OH2. Now let us see the procedure for ion exchange. So dear students, if you see the diagrammatic presentation, then two cylinders are there, two containers are there, one container with cation exchanger resin and second container with anion exchanger resin. There are two inlets at the top and two outlets at the bottom. If you see cation exchanger resin, then at the top two outlets, at the top two inlets, one for adding polluted water, or you can say the water to be treated, and second inlet is dilute HCl for regeneration. And cation exchanger resin is placed over perforated support, and if you see the bottom, then two outlets are there, one for collecting washing and second for getting a treated water. Likewise, if you see the anion exchanger resin, there are two inlets at the top and two outlets at the bottom. One inlet that is coming from cation exchanger, and second inlet that is the addition of NaOH solution for washing purpose. And then two outlets, one for collecting washing and second for collecting the water that we treated. So if we see the procedure, then first we have to add water in cation exchanger resin. So here first water pass through cation exchanger resin where all cations are captured. All cations like Ca2+, Mg2+, Fe2+, all types of cations get captured, and in exchange release of H plus ion. So that water enter in second resin, and second resin is an anion exchanger resin where all anions like Cl minus, SO4 2 minus, NO3 minus, means all negatively charged ions get captured and in exchange release of OH minus ion. So finally we get only water, that is a pure water, free from ions. That outcoming water is really free from ions or not, for that we are passing that water through X. X is a conductivity meter. If conductivity meter showing a 0 reading, it clearly indicates that water is completely free from ions. And if conductivity meter showing a reading, it means in outcoming water ions are coming, because you know very well for conductivity ions are responsible. So conductivity meter gives us idea about outcoming water, that is really free from ions or not. Then that water pass through Y. Y is a degasifier where all types of gases are removed. And finally we get a water which is completely free from ions, and that water called as a pure water. After diagrammatic presentation, you have to write the reactions during a softening, during a treatment. So first, as we have seen in the process, that first we pass the water through cation exchanger. So first reaction you have to write about the cation exchanger. And in the beginning I said, for writing a reaction, what are you going to use? You are going to use RH2. So RH2 plus Ca2 plus, or you can say RH2 plus Mg2 plus. Now here Ca2 plus and Mg2 plus are present in the water that entering in a resin, and that resin is RH2. So Ca2 plus Mg2 plus get captured. So in product you can see RCa, RMg, and what getting released? H plus ions are getting released. After that water pass through anion exchanger resin, and in anion exchanger resin I said in the beginning, for writing a reaction you are going to use R dash OH twice. So here water having anions, that anions entered in anion exchanger where all anions like Cl minus, SO4 2 minus get captured, and in exchange what getting released? OH minus ions getting released. So if you see the first exchanger, H plus released. If you see the second exchanger, OH minus release, and you know H plus and OH minus produces water. So what will happen if we carry out this process for long period of time? If we carry out this process for long period of time, then both cation and anion exchanger resins get fully exhausted. Fully exhausted means what? Here no H plus available for exchange, and for anion exchanger resin no OH minus available for exchange. So for cation exchanger we are going to use HCl for regeneration, and for anion exchanger we are going to use NaOH for exchanger. So here fully exhausted meaning what we have initially before treatment we have RH2, and after treatment for long period of treatment what will happen, that RH2 completely converted into RCa or RMg. Or if you see the anion exchanger resin, then R dash OH twice completely converted into R dash Cl2 or R dash SO4. It means that no H plus available for cation exchange, no OH minus available for anion exchanger. So here we have to do the regeneration. Now for regeneration, first reaction you have to write for cation exchanger resin. So here RMg, that is what? The exhausted cation exchanger. What we have to add from the top? We are adding HCl for regeneration, and we get RH twice again. And what getting released? MgCl2 getting released, and that MgCl2 coming out through washing. Likewise, you can write reaction for calcium. So in exam, either you have to write reaction for magnesium or calcium. No need to write both reactions. Now second is anion exchanger resin regeneration. In anion exchanger regeneration, we are going to use NaOH. That NaOH we are going to add from the top. So R-Cl2 or R-SO4, that is what the exhausted anion exchanger, and that getting regenerated by adding a NaOH from the top. And again we get active anion exchanger, that is what R-OH twice. And what getting released and that coming out through the washing, that is the NaCl and Na2SO4. So in this way, regeneration reactions we carry out for reactivation of exhausted cation exchanger and anion exchanger. As far as advantages are concerned, we get water which is completely free from cations and anions. That is what the water with zero hardness we get. Second thing, required small space and operation is very easier. As far as limitations are concerned, it required high initial investment and equipments are costly. And second thing, we use this method for small scale purification. So this is what the ions exchange method for getting water which is completely free from ions. So as per the demand of question, you are going to write the answer, and in that answer, if in question if they ask about to write the principle, to draw the diagram, then only you are going to write the principle and diagram. Sometime in question they will ask to write only reactions during a treatment and reaction during a regeneration. Then during that time you have to write only reactions during a treatment and reaction during a regeneration. No need to draw diagram, no need to write the principle. So kindly understand the question, and as per the question you are supposed going to write the answer. Hope you understood. Thank you for watching.